Hi friends, welcome back. Today we're talking about solving quadratics by completing the square. But before we can do that, what we first have to do is talk about perfect square trinomials. So we're going to do a quick refresh on that so you can see how those work. All right, a perfect square trinomial, this is the pattern that we have for it. X plus or minus y squared, quantity x plus or minus y squared equals x squared plus or minus, use whatever sign is here, 2 times x times y plus, this one's always positive here, y squared. Okay, so looking at this, then let's do some practice. For example, if we have this guy right here, and bear with me so that I can make sure that that's focused, x plus 5, quantity x plus 5 squared. If we have that, the way that we could say x plus 5 times x plus 5 and then FOIL it out or box method or however you wanted to, but instead what we can do is say x squared, and then we use the sign that's here, so plus. Then we take these two things and multiply them together. X times 5 is 5x. Double it, we get 10x. And then always positive at the end, and we take this guy and square it, so that's 25. So let's try that again. So in the front, we have this part squared, so 2x minus 3 squared, it's going to be 4x squared. Then we use this sign, minus, multiply these two things together, 2x times 3 is 6x, double it, we get 12x, plus whatever this guy is squared, so that's positive 9 there. Okay, so that is how you multiply those out. Let's talk about in reverse, how you have to factor those. So when we go to factor these guys, let's try this one. We'll do one at a time. This is really helpful when you see a perfect square in the front and a perfect square in the back here. Now is a good time to ask yourself, is it a perfect square trinomial? Let's try. If it was, we would do x, and then we use the sign in the front. So the square root of this, and then this sign and the square root of that, which is 9 squared. Now, how do we test? We take x times negative 9, and if you get x times negative 9, you get negative 9x. Double it, you get negative 18x, and sure enough, that's what we have here. So we have now factored this beautifully. All right, let's try this one. So again, we take square root of this, square root of that. So x and 11, we use the sign of the first one. And we multiply these two things together to get 11x. Double it, you get 22x. Yes, absolutely it is. All right, one more. This is where it's helpful, because if you have an a in the front of your quadratic, if you have something other than 1 here, it can be kind of a pain to factor it. So if you identify that this is a perfect square and this is a perfect square, good time. Let's test to see if it's a perfect square trinomial. Square root of this, use this sign. So 4x minus 3. 4x times 3 is 12x, double it, we get 24x. Bam, we have just factored that, made that so much easier. So this is really important when we go to when we go to complete quadratics by completing the square. Let's take a look at our first example here. So for this first example, the thing you want to do when you are completing the square is, this is one of the cases where in your quadratics, you want to get variables on one side, so get all your x's on one side and non-variables on the other. Okay, so what we do is we are going to say x squared, like this, minus 16x, and we're going to leave a space, equals negative 48. This one's already nice and put in order for us. Okay, so we've got, notice I left a little space there. That's because what we're going to do is I want to turn this side into a perfect square trinomial. And the way that I do that, if you remember back up here, if you multiply these two things together and double it, you get this. So we're going to be cutting it in half. So what I'm going to do is add parentheses squared. And if I do it on one side of my equation, I always have to do it to the other. Plus parentheses squared. Okay, what goes in here? Half of this middle term. So little side work here, and if I do quantity, and notice I use my sign, negative 8, negative 8. Little side work here. So what I have over here is x squared minus 16x plus 64, and if I factor that out, x, and I use the sign in the front, and then 64 is 8, so this would be x minus 8 squared. So essentially what that is you take one of these and one of these, and so we get x minus 8 squared equals, now a little side work here, quantity negative 8 squared is positive 64. So I have 64 plus 48, that's going to give me 16. Excellent. Okay, so now the idea is that we're trying to get this x by itself. So the opposite of squaring something is to square root it. And when I do that on this side, these guys cancel out, and I'm left with x minus 8 equals The square root of 16, remember, it's not just 4, it's positive and negative 4. My next step here is to get that x by itself, so I'm going to add 8 to both sides, and this is going to, oops, there we go. This is going to seem kind of weird, but what we're going to do is we're going to write it like this. X equals, you always put this one in the front, 8, and then you put your plus minus in the middle, so plus minus 4. This means that I get 2 answers here. I have x equals 8 plus 4, which would give me 12, and x equals 8 minus 4, which gives me 4. So those are my 2 answers. Now you want to ask yourself, how many solutions do I have? 2. How many should I have? Go back and look at your original equation, and that will help you. You should have 2. It's not always perfect, but you'll know why if it doesn't. So with that said, I like it when you write it like this, because when we have irrational solutions, it'll be a lot easier on you if you already are in the habit of writing it like this. Okay, so let's take a look at the next one here. We have x squared minus 12x minus 12. Now remember, I said variables on one side, non-variables on the other. So I'm going to add 12 to both sides. And when I do that, I end up with x squared minus, and these guys cancel out, minus 12x equals, and again, I'm leaving a space there because I'm going to add parentheses squared, add bubbles squared. I always say bubbles squared. I don't know, probably. I know you guys aren't that young. All right, so inside those bubbles, I'm going to put half of this guy right here. So negative 6, negative 6. Now, this is now a perfect square trinomial. I take one of these, x minus 6 squared equals, a little bit of side work over here. This is 36. Quantity negative 6 squared is positive 36. So that's going to give me 48. So I'm going to square root both sides because I want to get that x by itself. So this cancels out this, and I get x minus 6 equals. Now a little bit of side work here. Square root of 48. Remember, we can break that down. There's a perfect square hidden in there. 4 is hidden in there, but that's not our largest perfect square. Our largest perfect square is 16 and 3. If you need, you can go like 1 times 48, 2 times 24, 3 times, so you list all your factors, and as soon as you get to a perfect square, you know that that's your highest perfect square. The square root of 16 is 4, so 4 root 3. So really, the square root of 48 is plus minus, because we're taking it out of the radical, 4 root 3. Now, I want to add 6 to both sides, and again, I want to put that plus minus in the middle when I do this. So x equals 6 plus minus 4 root 3, and that is your solution. Now, how many answers do you have? You have 2 there. You have 6 plus 4 root 3, and you have 6 minus 4 root 3. So you have 2 solutions. How many should you have? 2. Excellent. You've done a fantastic job. Let's take a look at another one. All right, so for this guy right here, oh, this is a good one, because whenever you are completing the square, you are not allowed to have anything in your a, for your a term. So you can't have anything in front of your x squared, no matter what it is, because I'm going to divide everything here by 2. Even though 2 does not go into 3, this is going to be helpful. So what I have now is x squared minus 3 halves x minus 1 equals 0. Now remember, I said you have to have variables on one side, non-variables on the other, so plus 1. So x squared minus 3 halves x, I'm going to leave a space, equals 1. Now in the space, I'm going to put my bubbles squared, just like that, bubbles squared. Now what goes in the middle here is half of this. Well, we know it's going to be a negative. Now, how do I figure out what half of 3 halves is? Well, you take 3 halves, do a little side work here, you multiply it by 1/2, and that gives you 3/4. So half of 3 halves is 3/4. Negative 3 over 4. Negative 3 over 4. Okay, take one of these and one of these, so we get x minus 3 over 4 squared equals, now a little bit of side work over here. We have 1 plus, and remember, when we square something, when we square a fraction, we do it to the top and the bottom. So this is 9 over 16. Now 1 over 1, I can turn this into an improper, or I mean, I can turn this into, I can get common denominator. That's what I was looking for. Common denominator is 16. So instead of 1, I'm going to put 16 over 16, because that equals 1 plus 9 over 16, and that's going to give me 25 over 16. So all this garbage right here becomes 25 over 16. All right, now remember at this stage, we are trying to get our x by itself. So we are going to square root both sides. Bam, 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 you got it, bam, otherwise it doesn't work. So x minus 3/4 equals plus minus, because we're taking it out of the radicals. Now remember, square root of 25 over 16, give them a divorce and put them in the separate houses, because that right there means the same thing as this, and that is 5 over 4. So 5 over 4. Now we're going to add 3/4 to both sides. So what we have now is x equals 3/4 plus or minus 5/4. Okay, so now we're in a position to figure out what we've got. Right up there, we have x equals 3 plus 5 will give me 8 over 4, which reduces down to 2. And then x equals 3 minus 5 is negative 2 over 4, which reduces down to negative 1/2. How many answers do we have? 2. How many should we have? 2. Kablam. That is how you complete the square. If you have any questions, let your teacher know. Otherwise, great work. We'll see you next time.